Math Singer, yum!
Hello, and welcome to another Math Singer video. Today we're going to review a magic trick called casting out nines that has been used since at least the 1st century to check answers to addition and multiplication problems. This method was routinely taught in schools until calculators became ubiquitous, and it continues today to provide an entertaining insight into the nature of numbers. After reviewing the method of casting out nines, we're going to introduce a lesser-known technique for checking arithmetic problems that is called casting out 11s. After seeing these techniques in action, we'll explain why they work and learn why the names for these error-checking tools actually make sense. Let's begin by adding 47,626 and 31,477 together to get a sum of 79,103. We can check that this answer is correct by doing the following. First, begin by adding the digits of 47,626 to get 25, and then add the digits of 25 to get 7. Similarly, add the digits of 31,477 together to get 22, and then add 2 and 2 to get 4. Adding the 7 to the 4 results in 11, and the sum of the digits of 11 is 2. Now, notice that the sum of the digits of 79,103 is equal to 20, and the sum of 2 and 0 is also 2. Because the 2 from the first part of our calculation agrees with the 2 from the second part, we can be pretty sure that the answer to our addition problem is correct. A similar technique allows us to check answers to multiplication problems. Multiplying 47,626 and 31,477 together gives a product of 1,499,123,602. As before, 47,626 reduces to 7, and 31,477 reduces to 4. Multiplying 7 and 4 gives 28, which reduces to 1. Similarly, adding the digits of our product gives 37, which also reduces to 1. Therefore, we can be fairly certain that the answer to our multiplication problem is correct. As we've said, this technique for checking the answers to addition and multiplication problems is called casting out nines. While calculators have lessened the practicality of such error-checking techniques, casting out nines was absolutely invaluable prior to the 1970s, particularly for checking answers to multiplication problems, since it provides a very rapid method for checking answers to problems that are quite prone to human error. In fact, the method can be performed even more rapidly than we just presented it. Rather than adding all of the digits as we did, we could instead add digits until we arrive at a sum of 9 or greater, and then use the excess beyond 9 as we continue. For instance, we can reduce 1,499,123,602 as follows. Well, 1 plus 4 is 5, but 5 plus 9 exceeds 9 by 5, so we continue with 5. Again, 5 plus 9 exceeds 9 by 5, so we continue with 5 again. 5 plus 1 is 6, plus 2 is 8, plus 3 is 11, which exceeds 9 by 2. And finally, 2 plus 6 is 8, plus 0 is 8, plus 2 is 10, which exceeds 9 by 1. This shows again that 1,499,123,602 reduces to 1. Proceeding in this way provides some justification for why the name casting out nines is an appropriate description for this technique. We're now going to introduce a lesser-known error-checking technique for arithmetic problems that is called casting out 11s. Beginning with the 6 in the ones column, we're going to alternately subtract and add the digits from right to left. Well, 6 minus 2 is 4, plus 6 is 10, minus 7 is 3, plus 4 is 7. Similarly, 7 minus 7 is 0, plus 4 is 4, minus 1 is 3, plus 3 is 6. Adding 7 and 6 gives 13, and applying the alternating subtraction addition to 13 yields 3 minus 1, which is 2. Applying this alternating subtraction addition calculation to the sum yields 3 minus 0 plus 1 minus 9 plus 7, which is also equal to 2. Because the calculations agree with one another, we can be fairly certain that the sum is correct. When using our casting out 11s technique to check multiplication, we begin by applying our subtraction addition calculation to the numbers being multiplied together and then multiply the results to get 42. Applying our subtraction addition calculation to 42 gives negative 2. Well, anytime a negative number is produced by these subtraction addition calculations, we will add 11 until a positive number is reached. In this case, negative 2 plus 11 is equal to 9. Finally, we see that alternately subtracting and adding the digits of our product also produces 9. And this tells us that we probably carried out our multiplication correctly. To see why this method of casting out 11s works, observe that whenever 47,626 is divided by 11, the answer is 4,329 with a remainder of 7. Similarly, dividing 11 into 31,477 leaves a remainder of 6. As it turns out, the subtraction addition calculation that we've been performing is a technique for finding the remainder obtained when dividing a number by 11. In other words, 7 and 6 are the remainders that are left over after casting out all of the 11s from 47,626 and 31,477 respectively. Multiplying these numbers together produces a multiple of 11 plus 42, which can be rewritten as a multiple of 11 plus 9. In other words, the remainder obtained upon dividing the product by 11 is the same remainder that is obtained upon dividing 7 times 6 by 11. The explanation for casting out 9s is essentially the same. It follows from the fact that when a number is divided by 9, the remainder that we get is the same one we get if we add up the digits and divide by 9. So the method of casting out 9s literally begins by casting all of the 9s out of the numbers that are being added or multiplied, and then adding or multiplying the remainders. In fact, we can check answers to arithmetic problems by casting out 25s or 99s or, well, any positive integer at all. All we need to invent these methods is a way to identify the remainder obtained when dividing by 25 or 99 or whatever integer we're casting out. If you enjoyed this video, I hope that you will follow up by liking and subscribing. I also look forward to responding to any comments that you might have. For now, thank you for watching, and I'll see you in the next video.